Hello folks, welcome to the next video with linear equations and inequalities. We're going to pick up where we left off last time with linear inequalities, and one thing that I want everyone to be aware of is that linear inequalities and linear equations work much the same way when it comes to solving these things. So I have an example here. So on the left-hand side, you see that we have a linear equation, h plus 3 equals 5. So to solve for h, we simply just subtract 3 from both sides, and we find that h is equal to 2. Very simple equation. Well, the same thing is true for linear inequalities. We have h plus 3 less than 5. Again, we subtract 3 from both sides, and we get that h is less than 2, right? So with these equations and inequalities, we go through the same process when it comes to solving these things. But there is one slight difference. So that's why I've kind of broken this piece up into two videos. I have one that has to do with addition and subtraction, and then one that has to do with multiplication and division. All right, so here we go. Let's try one of these. Solve the inequality. So what we want to do is, just like with an equation, we want to get this x all by itself. So how do I do that? Well, I look at the operation that's happening to x, and then I perform the inverse operation, just like I did with an equation. And this little inequality symbol, well, it's just going to stay the same. So right now I have 6.2 less than or equal to x minus 4.5. So to get the x by itself, I want to undo the minus 4.5. So I add 4.5. And just like with an equation, whatever I do to one side, I have to make sure I do the same thing to the other side to keep that balance nice and balanced. So 6.2 plus 4.5 is 10.7 less than or equal to x. Okay. Second part says, now verify the solution. So what does that mean? Well, if we read this from the x, we know that x has to be greater than or equal to 10.7. So if we pick a value that is greater than 10.7, something like 11 or 12 or 13 or even 10.8, what we should find is that when we plug it back into our original equation, we should find a solution that satisfies the inequality. Or in other words, the right-hand side will in fact be greater than the left-hand side. So let's pick 11. So we get 6.2 less than or equal to 11 minus 4.5. So 6.2 less than or equal to, and 11 minus 4.5 is 6.5. And 6.2 is in fact less than 6.5. So we see that our value works. So we're pretty confident in our solution. When it came to linear equations, because we were testing the actual solution, it was very obvious that our answer was right. We have to be a little bit careful with these inequalities because there is a range of answers. It's not just one solution. It's a whole range of solutions that are either greater than or less than some value. We're going to find things like this where it looks like it's right, but it's possibly that it's not right. So if you really want to confirm that it's right, we should be picking numbers that are really close to 10.7, and we could even be testing multiple values just to make sure. All right, and then finally, if I wanted to graph the solution. So we know how to graph these from the last video. We're graphing this one. We're graphing the simplified solution. So instead of trying to figure out what the graph of the first thing is, it's when I've solved for x that I'm going to take it. I'm going to graph it. So x being greater than or equal to 10.7 means that I want to use a closed circle to represent the equals to, and I want my arrow to go to the right to represent the greater than. And that's it for the addition subtraction stuff. It's pretty straightforward because it works almost exactly the same as linear equations. But in the next video, we'll talk about the multiplication and division. And there is one little trick that we have to watch out for. All right, so I will see you all in the next one.